The equipment bonding jumper that runs from the transformer to the panel should terminate on the XO lug within the transformer enclosure. This is the correct and code-compliant method for establishing a low-impedance ground fault current path. The XO lug is specifically engineered and designated as the termination point for the equipment bonding jumper. Connecting the equipment bonding jumper to the transformer case, although it might seem like a viable option, is not the intended or approved practice. The XO lug is directly connected to the neutral point of the transformer secondary winding. This connection creates a solid grounding reference for the entire electrical system downstream. The purpose of the equipment bonding jumper is to provide a path for fault current to return to the source, which allows the overcurrent protective devices, such as circuit breakers or fuses, to quickly and effectively clear a fault. A properly installed equipment bonding jumper ensures that metallic parts of the electrical system are at the same electrical potential. This reduces the risk of electric shock. Now let's discuss the specific requirements outlined in the National Electrical Code, or NEC. The NEC provides detailed guidelines on grounding and bonding, which are crucial for electrical safety. NEC Section 250.24 C discusses grounding separately derived systems. This section mandates that the grounding electrode conductor be connected to the neutral point, typically the XO terminal, of the transformer. NEC Section 250.28 covers the requirements for bonding jumpers. It specifies that the equipment bonding jumper must be of sufficient size to handle the available fault current. NEC Section 250.102 describes sizing requirements for grounding electrode conductors and bonding jumpers. The size of the equipment bonding jumper is based on the size of the ungrounded conductors. These tables provide guidance on selecting the appropriate size conductor for the bonding jumper. Let's consider a typical scenario where a transformer supplies power to a panel board. The equipment bonding jumper would run from the XO lug in the transformer to the grounding busbar in the panel board. This connection ensures that the panel board and all the equipment connected to it are properly grounded. In addition to the NEC requirements, it's also essential to consult local electrical codes and regulations. Local codes may have additional requirements or interpretations of the NEC. Always follow the most stringent requirements to ensure electrical safety. Proper installation of the equipment bonding jumper is critical for safety. It must be securely connected to both the XO lug in the transformer and the grounding busbar in the panel board. All connections must be clean and free of corrosion. Use appropriate connectors and tools to ensure a reliable connection. Regularly inspect the equipment bonding jumper to ensure it's in good condition. Look for any signs of damage, corrosion, or loose connections. If any issues are found, address them promptly. Improper grounding can lead to dangerous situations, including electrical shock, fire hazards, and equipment damage. Understanding and adhering to the NEC requirements for grounding and bonding is essential for all electrical professionals. The NEC serves as a comprehensive guide for safe electrical installations. It's essential to stay up to date with the latest edition of the NEC. Changes and updates are made periodically to reflect new technologies and best practices. Consider attending training courses and workshops to enhance your knowledge of grounding and bonding. Continuing education is crucial for staying current with the latest industry standards and best practices. Always prioritize safety when working with electrical systems. To energize circuits before working on them, use appropriate personal protective equipment, or PPE, such as gloves and safety glasses. Follow lockout-tagout procedures to prevent accidental energization of circuits. The equipment bonding jumper plays a vital role in protecting people and equipment from electrical hazards. By properly installing and maintaining the equipment bonding jumper, you're contributing to a safer electrical environment. Let's delve into some more specific aspects of transformer grounding and bonding. The size of the equipment bonding jumper is determined by the size of the transformer's secondary conductors. The larger the secondary conductors, the larger the equipment bonding jumper needs to be. The NEC provides tables that specify the minimum size of the equipment bonding jumper based on the size of the secondary conductors. These tables take into account the available fault current and the need to provide a low impedance ground fault current path. In addition to the equipment bonding jumper, it's also important to ensure that the transformer itself is properly grounded. This typically involves connecting a grounding electrode conductor from the transformer case to a grounding electrode, such as a ground rod or a metallic water pipe. The grounding electrode provides a path for fault current to flow to the earth, which helps to stabilize the voltage and reduce the risk of electric shock. The grounding electrode conductor must also be of sufficient size to handle the available fault current. The NEC provides tables that specify the minimum size of the grounding electrode conductor based on the size of the transformer's secondary conductors. The location of the grounding electrode is also important. It should be located as close as possible to the transformer and should be protected from physical damage. The grounding electrode should also be installed in accordance with local codes and regulations. When installing the equipment bonding jumper, it's important to use the correct type of connector. The connector should be listed and labeled for the specific application. It should also be compatible with the type of conductor being used. Avoid using dissimilar metals for connections. Dissimilar metals can corrode over time, which can weaken the connection and increase the risk of electrical failure. Use an antioxidant compound when connecting aluminum conductors to prevent corrosion. An antioxidant compound helps to prevent the formation of aluminum oxide, which is a poor conductor of electricity. Regularly inspect connections for signs of corrosion. If corrosion is present, clean the connection and apply a fresh coat of antioxidant compound. When tightening connectors, use a torque wrench to ensure that they're tightened to the correct specification. Over-tightening can damage the connector or conductor, while under-tightening can result in a loose connection. Follow the manufacturer's recommendations for tightening torque. After installing the equipment bonding jumper, test it to ensure that it's functioning properly. Use a low resistance ohmmeter to measure the resistance of the bonding jumper. The resistance should be as low as possible, ideally less than 1 ohm. A high resistance indicates a loose connection, corrosion, or other problem. Troubleshoot and correct any problems before energizing the circuit. In addition to the equipment bonding jumper, other bonding connections may be required. For example, metallic conduit and enclosures must be bonded together to ensure that they are at the same electrical potential. Bonding can be achieved by using bonding jumpers, bonding bushings, or other approved methods. The goal is to create a continuous, low-impedance ground fault current path throughout the electrical system. Let's discuss some common mistakes to avoid when installing equipment bonding jumpers. One common mistake is to use the wrong size conductor. Using a conductor that's too small can result in a high impedance ground fault current path, which can delay the clearing of a fault and increase the risk of electrical shock. Another common mistake is to make loose connections. Loose connections can also result in a high impedance ground fault current path. Over time, loose connections can become corroded, which can further increase the resistance. Another common mistake is to use the wrong type of connector. Using a connector that's not listed and labeled for the specific application can compromise the safety and reliability of the connection. Another common mistake is to fail to properly torque the connectors. Under-tightening or over-tightening connectors can damage the connection and increase the risk of electrical failure. Regularly inspect your work and correct any mistakes promptly. Attention to detail is crucial when working with electrical systems. Now, let's delve into some advanced topics related to transformer grounding and bonding. Ground impedance is a measure of the opposition to the flow of ground fault current. A low ground impedance is desirable because it allows fault current to flow quickly and easily, which helps to clear faults quickly. Ground impedance can be affected by several factors, including the size and length of the equipment bonding jumper, the type of connectors used, and the condition of the connections. Ground fault loop impedance is the total impedance of the ground fault current path from the source of the fault back to the source of power. A low ground fault loop impedance is essential for ensuring that overcurrent protective devices will trip quickly in the event of a fault. Ground fault loop impedance can be measured using a ground fault loop impedance tester. This tester applies a small amount of current to the ground fault current path and measures the voltage drop. The impedance is then calculated using Ohm's law. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect people from electric shock. GFCIs work by monitoring the current flowing in the circuit. If there's a difference of more than a few milliamperes between the current flowing to and from the load, the GFCI will trip, interrupting the circuit. GFCIs are commonly used in wet or damp locations, such as bathrooms, kitchens, and outdoor areas. They are also required in many other locations by the NEC. Surge protective devices, or SPDs, are devices that are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, switching operations, or other events. SPD work by diverting the surge current to ground, protecting the equipment from damage. SPD should be installed at the service entrance and at other locations where sensitive electronic equipment is located. Harmonic currents are currents that are multiples of the fundamental frequency, which is typically 60 Hz. Harmonic currents can be caused by nonlinear loads, such as electronic devices, fluorescent lighting, and variable frequency drives. Harmonic currents can cause a variety of problems, including overheating of equipment, increased energy losses, and interference with communication systems. Harmonic filters can be used to reduce the levels of harmonic currents in the electrical system. Electrical codes and standards are constantly evolving. It's important to stay up to date with the latest requirements. The NEC is updated every 3 years. Consider joining professional organizations such as the Institute of Electrical and Electronics Engineers, or IEE, or the International Association of Electrical Inspectors, or IE, to stay informed about the latest developments in the electrical industry. Attend industry conferences and workshops to network with other professionals and learn about new technologies and best practices. Continuously strive to improve your knowledge and skills. Electrical safety is everyone's responsibility. By following safe work practices and adhering to electrical codes and standards, you can help to prevent electrical accidents and injuries. Remember to always de-energize circuits before working on them, use appropriate personal protective equipment, and follow lockout-tagout procedures. When in doubt, consult with a qualified electrical professional. Let's recap the key points. The equipment bonding jumper must connect to the XO lug in the transformer. This provides a low impedance path for fault current. Proper sizing of the bonding jumper is critical. Consult the NEC tables for guidance. Secure and corrosion-free connections are essential. Test the bonding jumper after installation to verify its integrity. Staying informed about electrical codes and best practices is important. Safety is paramount when working with electrical systems.